So if it's fine with everyone, then please share your slides and yeah, take it away.
Okay. Sharing my screen now. Can everyone see that okay?
Yes, okay.
Excellent. So, hello everyone. Thank you, Anna, for that introduction. As Anna said, I'm Daniel Camilleri. I'm the CEO of a recent startup called CyberSelves. And today we're going to be talking about sort of programming your robot in more human terms. But sort of before we do that, we have to acknowledge that sort of this year has been, you could call it the year of the robot. Well, 2020, robots, there was an uprising, so to say, with a lot of robots being used for different applications where, you know, previously they weren't. Robots for disinfecting, robots for visiting patients in the hospital. And so we saw the sort of an increase in the use of robots within more sort of social, let's say, scenarios outside of the industrial workplace to help us with things like distancing, to perform tasks that would otherwise increase the rate of infection. But as you all know, this is the pain of robotics, is that every system that you touch has its own ecosystem of software. Most of the time, its own bespoke software. So, for example, on the screen, we've got 4 different ones, only one of which uses ROS. But even when you've got multiple robots using ROS, the problem still lies is that different ROS robots are still not plug and play. So I can't simply remove one robot from one manufacturer and instead put in another robot from another manufacturer and use that robot without any changes to the client software, to the applications that are actually running via that robot. And so this has led us to sort of identify 3 regions, 3 problems within robotics, which are holding it back from achieving sort of the same mainstream adoption as you have, you know, a laptop, a computer, or a phone, you know, smartphones. Robots, I believe, are the next generation, the 3rd generation of personal devices. But before we can get there, we need to solve these 3 problems. And so, first of all, the one which is closer to me is, you know, different robots are programmed differently. Every time you switch a robot, from my experience, I spend a couple months learning about that robot, learning about its inputs and outputs, before I can then start working on translating algorithms I created for other robots so that they can work on this robot. And so that is, in my opinion, the first issue. Different robots programmed in very different ways. And then the second issue is more of a commercial issue, in that without means for programming different robots in the same way, you end up with a severe lack of applications available for commercially available robots. So you're able to buy a Pepper robot, but if you're a business and you want to use that Pepper, let's say, as a concierge, or you want to use that Pepper for different functions, it's not possible to go online, find an app that you can just download and run on the robot to actually serve that purpose. And so we see from our experience in CyberSelves, from the different events we've done in the past before spinning out, we've seen a lot of businesses who have actually invested and bought robots, but in the end, they're just lying in the corner gathering dust because they can't find the software to go alongside the robot. And the third problem is that creating a robot and taking that to market is also really expensive, because if you're a robot manufacturer creating a robot, you first need to create the hardware, but you can't stop there. You need to create the software to interface with the hardware, maybe a communication layer for connecting to that robot, an SDK for developers to use so that they can develop applications for your robot, and then online systems so you can manage that robot if you're a business, and then the applications that would entice or attract the actual customers to buy your robot for this specific application that they're looking for. So we see these three problems. They feed into each other. They're very tightly knit. And we believe that sort of at CyberServes, our mission is to realize the true potential of robotics by solving these three problems. And at the core of the three problems is a standardization of how we think about robots and how we think about these different systems of hardware and sensors, actuators and sensors, and how do we abstract away the differences of different robots so that we can program them in a coherent and unique and sort of more standardized way. And so we've created Animus, which is our software. I think I might have. There we go. Animus, which is a robot agnostic software library. And what that does is it standardizes the way we program robots. And by doing so, we end up with reducing the manufacturing costs for robot manufacturers, first of all, because they can now focus on the lower level hardware and the software to interface with that specific hardware. But then through standardization, the rest of it is completely the same. So robot developers can create applications which run on robots which haven't even been created yet. And the robot manufacturers can deliver their solutions to market even quicker. And combining all this, it all leads to robot users becoming more frequent because they've actually got the functionality that they need. And so Animus abstracts away the differences for each robot, and we'll talk about it in a couple slides as to how we actually approach this. And that is where thinking about robots in more human terms comes into practice. But before that, I just want to talk about sort of other features that Animus has, and that is the fact that you can use Animus to connect and control robots over the internet with connections and speeds that are 4 times faster than your regular video call. And it is so much more easier to program, again, because we take a more human approach to programming these robots. And continuing on the path of what makes it unique, in comparison to other robot programming languages, robot SDKs, our Animus, our software SDK, is supported by multiple programming languages and even any operating system. So it was always an issue with me sort of programming robots in that, I always have to work in Linux, and then it's usually either C++ or Python to create the applications that I'm doing. So I think that needs to change. And with Animus, you can actually program, connect to, and control robots remotely from any operating system, whether it's a desktop operating system, whether it's a mobile operating system, and with your programming language of choice. And these are all the robots that we've integrated with Animus over this past year and a half since we've started. And you can see that there is a big mix of different robots. We've got humanoids of different heights and sizes, different capabilities in terms of grasping. We've got non-humanoids. We've got sort of animal-like robots, and even underwater robots, underwater ROVs, all controlled from the exact same code, and all able to interface seamlessly and in a plug-and-play way with any client applications that are using Animus, and also talk about sort of our key application later on and how that fits within the Robotics team. And so here's a list of the advantages that we offer to robot manufacturers, and that is, instantly internet enable your robots so that you can remotely connect to and control robots with really low latency. Simplifying the development because developers can easily create Animus apps and control robots from any operating system. And also that it's lightweight and portable. Well, 30 megabytes is a bit outdated, but 100 megabytes today gives you everything you need as a local installation without compiling anything else, everything that you need to control your specific robot, completely remotely and with really low latency. So how do we make Animus robot agnostic? This is the key question. And sort of our guiding principle is that Animus needs to act as sort of a nervous system, a universal layer between the body and the brains, the actual applications controlling the robot. And so the solution for us is grouping robot input and outputs into what we refer to as sensory modalities. And those are the different senses that, if you think from a human perspective, we've got vision, we've got audition, we've got touch, we've got a certain means for moving, which is usually also moving in a task-oriented fashion rather than actually us calculating, oh, I need to move this joint at this angle, this joint at this angle. And so what we do to standardize the control of the different robots is we group perceptions, stimuli, and actions into named categories, which are also directional. So, for example, from the perspective of the brain, from the perspective of the application, vision is an input. You sample vision, you process it, and then you output motor control, a motor command. And so here's an example of how we do that. We can group all of the cameras into a single vision modality. You group all of the microphones into an audition modality. Now, within that modality, you have all the information that you need, such as the current position of that microphone with respect to the robot's body, the data that it's currently received, maybe some more information about the actual types of information that you're receiving. But from the client end, all that the programmer needs to think about is, I want to sample the vision modality. So robot.getVision. That's it. That gives me all of the visual information I need, whether it's a humanoid robot, whether it's ground-based, underwater, hell, air, space. And so we perform this mapping, this sort of robot-to-human mapping for all the robots within our stable of robots. And this is how we abstract away the differences from the different robots and make it actually plug and play on the client side. So here's the anatomy of an Animus application. So using the client SDK, this is the sort of pattern that a developer would follow. They'd log into their account. That gives them access to all the robots that are available to them anywhere in the world, all remotely. Then they can connect to one or more of the robots available. And then they open the modalities for the set of required modalities. So if I want vision and motor, I can simply open those. If I want more modalities, audition or voice, I can also open those. But it is very bandwidth efficient, and you can only open the set of inputs and outputs that you need from the robot. And then finally, you start your sensing, decide, act loop. You get the modality by passing in the modality name. that receives all the data in a standardized format, irrespective of the robot. You can then process that data, make a decision, and then set an output, again, in a standardized form, and send that to the robot, and the robot then interprets that and carries out that particular action. And finally, when you're ready, you disconnect from one or from all your robots, and you just close the whole application. So that is the goal here. That is making the programming of robots as simple as possible and as sort of human-centric as possible. So you can think about breaking down a particular robot application by thinking about yourself and how you would, if you were a robot, carry out these actions. What are the decisions I would take? Which sensors am I sampling? And this is the whole infrastructure that we've created in the background. So we've got in the lower left, we've got the Animus client side. That's the one that we've just talked through. And then on the back end, we've got all the services supporting the tracking of robots, sharing robots in between users, connecting to them remotely, and also controlling them after you've established a connection. And that leads us now into the sort of the main application, the very first application that we've created with Animus. And this application for us is a means of demonstrating what's possible. And that for us is Telepresence, which fits very well into robotic applications in terms of using Telepresence to supplement the applications running autonomously on the robot whenever those applications encounter situations that they don't know how to handle or they can't handle. And so that's when you can introduce a human in the loop to actually take over. And I'll show you guys a video of Telepresence application we demonstrated to the BBC a couple of months ago. Can you hear the audio?
Robocop, how about RoboDoc, a scientist?
Yes, we can.
Yes, we can.
Could soon become a reality.
Yes, a team at the University of Sheffield have received government funding to develop ways of using new technology in hospitals and care homes, as Lakshmi Gopal has been finding out.
This is Benny the robot. He's in a home lab in Sheffield, but he's being controlled in real time from Manchester. Through the technology, anyone, anywhere can immerse themselves in the robot.
I become the robot simply by putting on a VR headset. And now I can see everything the robot sees. And I can control its arms.
Robotics firm CyberSelves has developed a versatile, more user-friendly programming system, so what robots can't yet do alone can be done with the help of human controls. They hope it'll revolutionise health tech.
There's an increasing use of robots in healthcare right now, but the artificial intelligence that powers those robots isn't quite up to scratch. And the programming is very, very hard. It requires incredibly specialist degrees to program robots. So what we're trying to do is simultaneously make it easier to control robots and also to make up that gap for the artificial intelligence. So a robot moving around a hospital, let's say cleaning a ward, will get stuck or won't know how to do a certain task. A human being can enter into it, perform the task, and the robot can then learn in the future from that as well.
The same system can be used to control any number of robots to perform a whole range of different tasks, from surgery to bomb disposal, or, for example, in care homes, as a way of having COVID-safe company. No social distancing needed here. It's the closest to being with someone without actually being there, and opens a world of possibilities.
How are you today? I've got your medicine right here.
The doctor could be hundreds of miles away. Could be some specialist that you would like to see a patient and they might be in New York, and they just need to put on a VR headset and they could be in Sheffield looking at this patient.
Can you look to the left for me, please? And to the right?
You're saying, well, can you show me your leg? And you can look at the leg, you know, and you can do that just as if you were in the room. It's the naturalness and the spontaneity of it which is going to make a difference.
The team's work is already making a difference, here in Italy, guiding people with limited mobility through tasks and drawing conversation from autistic youngsters who otherwise struggle with social interaction. They've now received government funding to explore new ways of helping healthcare through robots like Benny here in a COVID world and beyond. Lakshmi Gopal
and Villani for BBC News in Sheffield.
It's a glimpse of the future, that.
Wow.
So that is the how we're using Telepresence at the moment, and we offer, based on Animus, because of its modularity, we can offer any range, any variety of telepresence solutions, from low immersion, where it's just audiovisual, to more high immersion, where you've got other modalities such as haptics, force feedback. And this is what we're working on as part of the ANA Avatar X Prize competition, of which we are semi-finalists. And this is really just for us a test of how far can we push Animus in it being as robot agnostic, as fast as possible, and providing a range of solutions to the problems in robotics today. But beyond that as well, with the use of a standardized representation for all the information coming from robots and being sent to robots, it also offers an exciting possibility to create what I like to refer to exponential AI, an AI application where you've got multiple robots carrying out different tasks on day one. You're collecting the information from those robots. The tasks could potentially be carried out by humans, and the robot is collecting the sensory information while those tasks are being carried out. But in the end of the day, you're training your AI applications. And because of the standardized nature of Animus, the next day, all these 5 robots can now perform, at least in a recorded way, if not more intelligently, the same 5 tasks that were recorded on 5 different robots. And that, to me, is an exciting avenue that I believe should be explored to really take us forward to the next generation of robotics. And I'll leave you with the final video for this is a video we recorded for our X Prize competition. And that's it from my end.
Thank you. It's 4 minutes, the video. We cannot afford 4 minutes, Daniel.
No worries. Yeah, so that's why I'm closing off whichever point that so we can just move on.
We're way out of time. Good, but this is an interesting challenge that you're posing, an interesting solution. Although I see there are some indeed challenges for some implications for embodiment and ownership and the sense of the self, right?
Yes, very much so.
For both the robot and the human.
Mm-hmm.
So there will be some interesting implications about your solutions. But then I have to then thank you, Daniel. We can learn certainly a little bit more in the future, because now we know where to find you, find your solution. So, and with that, I thank you.
Thank you so much.
You can stay. Maybe we can have some final discussion. I'm sure there will be some curiosity and some questions. So I invite then Matthias Pock for the next talk.
How many minutes, Anna?
Sorry, I said I see Daniel and I see, you're both there. So yes. Can you start your presentation, Matthias? You're also looking.
Yeah.
Can you hear me?
Yeah. Okay. The minutes are 20 per presentation.
Yeah, they're very exciting talks. So it's fine.
I can keep it shorter. So I just need to know. So
now we see you. We see you. We see it inverted, but maybe the slides are not inverted. Maybe you have to find a way. Yeah, perfect.
Can you hear me as well?
Yeah, perfectly fine. Yes, okay. Super.
Let me just start the timer.
Don't worry, don't stress out too much. It's fine.
Yeah. Okay.
So,
thank you very much, Anna.
yeah,
As you just heard, we now enter into a session which leaves the technologists and the entrepreneurs, and two social scientists come into play and will give their experience with the ethical and legal challenges. I had a talk with Nikos, the other speaker, yesterday, so it was a very fruitful discussion, and I hope we can continue here.
Yeah, that's right.
Yeah.
Thank you.
The title of the presentation is a little bit misleading because the ultimate goal is to have legally compatible, standardized way to design technology. In the REHIB project, we are at a stage where we are not there yet because we are still having to develop a lot of things before we can really exploit the technical specifications in standardization bodies. But the way is there, and the methodology is also made to go there. This is like the previous presentation. This is about the application domain of healthcare. And just a short introduction. My organization is based in Hamburg, Germany, and I'm specialized in data protection and privacy in the design and development of new ICT. With the legal career, it may be a little bit unfamiliar to technologists. So I will go a little bit into what's my background. The background is special in terms of having a legal background, but being engaged in technical standards committees. So trying to find technical answers to legal challenges in support of what's already there on the policy level and on the legislation level. So there are two main areas. One area is cybersecurity and data protection. I'm involved in the Sensenelec Joint Technical Committee 13, but also chairing a technical working group on cybersecurity. The other one is the Technical Committee on Health Informatics. They are the ones dealing with health data and health processes, ICT processes. And there's a CEN group, a European group, but also an ISO, an international group dealing with these kinds of topics. And as I said, the ultimate goal is for us to not only give recommendations to the legislators in the legal terms or the policymaker, but also to give specific technical specifications to the standards development organizations. And this is just a list of what kinds of topics have been relevant previously for myself, and in the REHIB project, it will be different deliverables coming out. So in the REHIB project, we are having a dedicated work package on ethical and legal issues. Of course, we will talk about patient autonomy, privacy and data protection, social interaction, liability effectiveness. And there is more the practical issues of managing ethics, like for the pilots, and evaluating the system against that. We are dealing with stroke survivors, and we're using robotic technologies. And I guess you have already heard a presentation on related to the REHIB project maybe this morning. I'm not sure, but so sorry for my ignorance, but let me just refer to that, the kinds of technologies covered on this slide. Okay, we have another work stream which is dealing with the analysis of the ethical and legal issues. So as I said, trying to make technical specifications, giving emphasis on, in this case, it's about protection of personal data, positioning the system against frameworks that are already out there on the regulatory level, and giving some assessment of the risks and the shortcomings of the systems before going into commercialization. And a third work stream is dealing with the practical project issues of managing ethics. And we don't only have these different deliverables and work streams, but also we have a decision-making or an advisory body within the consortium. And this one is really collecting all the project partners into one forum to discuss and share lessons learned about the legal and ethical challenges. This is just the kind of methodology which we will use for the project and which we have already used for the project is to involve volunteers in digital twin model generation, interface design, interviews, and having a pilot trials to demonstrate the use cases. We have clinical partners in the consortium, so they will be the ones to validate the...
Matthias, can I interrupt you for a moment? So the idea was to see if, let's say, the ethical policies and the ethical guidelines for technologies that are used in industry, like automotive or disassembly kind of technology is different. So if the ethical and the consequences and the regulations are different, whether we're applying one type of industry to another. Not to go into the details of the project, because this is a little bit far from, you know, we're dealing with stroke patients in the case of rehab, is a little bit far from the topic that we have been looking at it this morning. Was more like, okay, are there fundamental differences in the way technology, robots, because rehab will be using robots, for instance, will be using AI. Are there fundamental differences, whether we're looking at industry like health or industry like disassembly or electronics or automotive? So this is a little bit the flavor that I was hoping you guys, you and Nikos would bring to the table today.
Right.
Yeah, okay.
There's always this, thanks for the clarification in here. In standardization, there's always the discussion about the vertical and the horizontal regulatory approaches. And for example, if you have privacy, data protection, and cybersecurity or safety, you have both. You have the generic safety, security, and privacy standards, but you also have the vertical ones, which are dealing with health ICT, with energy, with transport, etc. So it's always a delicate balance between the two, and oftentimes the specialized committees. In this case, it's the healthcare committees that I'm familiar with. They are sometimes using generic standards to extend them. And other times they are using, they are developing, they are the pioneers, and they are developing the privacy or security standards first, before the more general groups are addressing the issues. For example, one is the standard on pseudonymization, where you would expect that the privacy standards group would be the lead and first develop a general framework. But it was not the case. The case was that the healthcare application domain was the first to come up with a pseudonymization standard. And then only years later, the Privacy Standards Committee was developing a de-identification techniques standard, and that was many years later. So you have both approaches. Sometimes they are combined, and in many other cases they are not combined or coordinated at all. So it's always takes a very deep analysis to identify on a case-by-case basis what's really needed. And and some standards are used more often than others, and that's also the case. And you can't say that in the case of the pseudonymization or the de-identification standard that one is overlapping the other, but of course they are. But you need to see what is more useful in the specific case. So that would be like a general remark about this. You have both. You have even three approaches. You have the ones where the industry specific, the vertical standards or regulations are first and then complemented by more generic ones, or you have the other ones that are generic and then may be applied to the application domain, like the one standard I mentioned on privacy management in health data is the application of a generic privacy management standard. And then you also have cases where you just rely on the generic one or just rely on the specific vertical regulation or standards. Yeah, that would be the first thing that comes to my mind when you raise this point here. I'm not sure if we then need to continue with the presentation. We can have this kind of loose discussion, I think, then as a next step.
Because here you go in more details into the REHIB project, right? That or also it would be interesting to see the application of AI, the ethics guidance. I see that you have some relevant information here.
Yeah. So one of the two innovations here is not only trying to contribute to technical standards in the domain of robotic or in the domain of healthcare ICT, but also to pilot the so-called Trustworthy AI ethics guidelines, which were developed by the European Union's, the European Commission's high-level expert group on AI. And the reason why this is innovative from a more social scientist perspective is that it provides a standardized way of assessing these kinds of ethical challenges, where usually you are dealing with legal or ethical partners in a project and they all do their own thing in terms of how they present the topics and how they evaluate and assess the different topics. And in this way, we have a standardized way to cover the different ethical dimensions of a project. So this is one activity in addition to what we do to technical standardization. Right, and yeah, I think that's the most relevant things then from what I have learned from you.
Okay, so maybe what we can do is to see what Nikos has to will present, and then we can take it from there and discuss on the similarity or the divergence as well. Or because I see that also in industry, especially having listened this morning all the talks, there is a lot of data that will have to be transferred and that will have to be managed. So it's also in the case of the health domain, where there's a lot of data to be protected and to be managed. The same applies to the workers in the industry or the robots in the industry and so on. So in terms of data, there are a lot of similarities. I imagine, as you were mentioning, this vertical settings that apply to any standard ethical domain, I suppose. So let's see, maybe Nikos then.
Yes, and I would also invite the audience to share some experience, because maybe not so much on security and privacy, if that's not the main expertise, but I guess many participants here have some link to standardization, be it for safety or be it for effectiveness of technologies, interoperability. And then we would have this, I think, a similar kind of discussion as to the horizontal versus the vertical approaches. I believe that would be interesting for me as well.
Okay, let's see. So then we keep it for later. We hear from, or anyone wants to share some information here about data management, security, privacy, maybe. Okay. We leave it for later. So Nikos, are you there?
Hi, Anna. Do you hear me?
Yeah, I do.
Okay, perfect. Yes, I'm here then. So I think I'm going to conclude this workshop now with my presentation, which I will try to keep it short, less than 20 minutes allocated to me.
So Sarah will be very happy.
Yes, for sure. I will be watching you.
Okay, so go ahead. I see an amazing green screen right now. I don't know what it means.
I think this is not mine.
This is Matthias. This is Matthias' screen.
So Matthias, maybe you want to stop sharing? Yeah.
Yeah.
I would like you to confirm that you see the whole screen of mine.
Yeah. Just put the presentation mode.
And this I hide.
Okay.
Yes. Therefore, I'm going to start, and I'm going to speak about the human factors in industrial settings, and specifically about ethics and how they are integrated in the context of the project HR Recycler. On behalf of the legal and ethical partner, which is us, VUB, the University of Brussels. First, I'm going to introduce myself very briefly. Personally, I'm a lawyer and a PhD researcher in a sub-unit of VUB, dealing with legal and ethical matters in societal and legal and technology studies, or STS studies. In this project, we are contracted, let's say, we are involved in the legal and ethical part in work package 2 specifically, to identify the legal and ethical, again, risks and impacts as well of the project, and specifically for the human and robot collaboration in industrial settings. My personal expertise is the fundamental rights of data protection and privacy, which are distinct to each other. And for the sake of this project, the part of ethics. As a first remark, I would like to say that ethics are identified in this project through the means of the impact assessment. The project has a central point, like a comprehensive mechanism, let's say, to identify the risks which stem from these kind of activities. And the legal and ethical partner is performing the process of impact assessment, which has 5 elements. As you can see, these 5 elements.
Nico, sorry, you're not changing slide, right? We don't see your presentation.
No, I have changed slides.
No, we don't see your slide. So
sorry, do you see now?
Yes, can you put it in the presentation mode?
Yeah, I will try.
It's difficult. If
do
not,
you see the change now?
Now it changed, yes.
It changes.
We see another slide, but not in the presentation mode. You can leave it like this, it's fine.
But do you see the slide of the notion of impact assessment?
Yeah, we do.
Okay, and do you see now the slide that you missed? The about slide or not?
Yes, we see the notion of impact assessment.
Okay, you see this one, but maybe we will miss the next one as well.
I don't know. Did you change?
You don't see any change then?
No.
Okay, I will do presentation mode again for every slide then. Okay. But is it fine if it's like this?
Yeah, it's fine. Go ahead.
Okay. So first, I'm going to explain the notion of impact assessment, which has 5 elements in total, and they are one is informing the other, of course. First, we need a team of assessors to analyze the consequences, the risks which stem from some societal concerns. And this one is a factual concern, such as the human-robot collaboration. Afterwards, the assessors or whoever is performing the impact assessment is analyzing the risks and the dangers which come from these concerns. And the impact assessment itself is a tool for informed decision making. For instance, to substantiate some concerns or to anticipate some negative consequences. The purpose of the impact assessment is also to protect these concerns, mostly societal. And fifth element is the phase of recommendations through the mitigation of these negative consequences and the risks. And so this is the tool for integrating the ethics part as well in the project, the human-robot collaboration. For this one, we have developed a framework which we have named TARES, but this stands for truthfulness, authenticity, respect, equity, social responsibility. And for that, we identified more than ethics in the project, and we integrate 3 kinds of impact assessment in it. First is the data protection impact assessment, which is legally mandated by the new GDPR, the General Data Protection Regulation. And essentially, this one is a tool for identifying the risks to data protection, the fundamental right to data protection. Secondly, we include the ethical and societal concerns through the mechanism of the ethical impact assessment. And third, and as I said in the beginning, privacy is a distinct right from data protection. We include also private impact assessment as a tool for identifying the risks. So as a matter of fact, privacy is different from data protection in a sense that data protection, the legal framework is triggered whenever we have personal data. However, it might happen that something interferes with the privacy of a natural person, a human, without specifically having to do with personal data. And this can happen when we are in an anonymous environment. However, a human is interfered with the right to his or her privacy. Next, I'm going to briefly speak about the method of impact assessment and how ethics are addressed, ethical concerns are addressed. Firstly, it's just the phase I'm going to explain, so for the sake of time, the preparation of the assessment process, which includes the identification of the ethical concerns, among others. Secondly, is the step of assessment, which is the description of how some interactions might create negative consequences as regards with the ethics, or also legal repercussions. The third phase is the monitoring and review, which essentially means the continuity of the impact assessment. And fourth, we can have additional steps such as the stakeholder consultation, which is the inclusion of third parties, for example, involvement of them, and the documentation for evidence reasons, and the quality control by external bodies. I have created here a bipartite part on the repercussions of the impact assessment. So the first one is on data protection. For example, the human-robot collaboration on the HR Recycler project has proven that legally speaking, there are not a lot of risks which can be grave for the natural persons, and there could not be any chilling effects, which means there could not be secondary or collateral, let's say, consequences on them, and they are also limited in time. And some measures, as I said, there are recommendations also which can be included. Some measures for that could be the blurring of faces or the direction of cameras in parts where workers are not really faced by the camera. But most importantly, when it comes to ethics, because this is the focus of this presentation, is, for example, we need to have informed consent procedures, which means that apart from the legally mandated and prescribed in the law, a procedure for obtaining the consent as a valid mechanism, it's also an ethical point of concern to have informed consent in these environments, so that the autonomy of the workers is not compromised. Secondly, their feedback is valued, and this has to be pursued throughout the whole duration of the project, in the beginning, middle, and the end. And this can also change as the time goes by. More specifically, as I said, first and most important maybe is the obtaining of the free consent from workers, which is, for example, not to be obtained through a proxy also. It has to be obtained directly and specifically by them. The information part, the provision of information to whoever is involved in these settings, is also both a legal and an ethical requirement. The proportionality, which can be summarized in the retainment of control from the worker instead of the robot in this case, and then the adaptation of the robot to the personality of the worker. This is very important. Some extra points of concern are more abstract, which can also be met in the ethical principles: autonomy, of course, of the natural person, of the human, the allocation, proper allocation, and fair allocation as well of roles and tasks between the robot and the worker, the moral agency, which is the extent to which a robot is assuming responsibilities from the worker as well, the trust, the safety and avoidance of harm, physical harm, moral harm as well. And the last two are also legal concerns: explainability or interpretability, sometimes explainability of how one automated decision is reaching to, how a robot is reaching an automated decision, and means to explain how and why it has reached to this decision, which has to be provided to the human. And then the bias, it's the avoidance of discrimination or unfair treatment, etc. More practically, I would like I have put here for you to illustrate some risks, as I said before, and then the impact which stems from these risks in the second column. And then third, fourth, and fifth, we have the calculation of the impact. So I'm not going, of course, to go through all of these, but I have pointed out with these blue arrows some of them which might produce higher risk. For example, let's go to the highest risk, which is number 30, societal conscience related to new robotic era. This is kind of abstract and conceptual as a thought. So this is the risk. You see that the description of possible impact could be that it creates stress and the feeling of surveillance to the workers. And then the team of assessors or whoever performs impact assessment calculates the likelihood, the possibility. And we here have identified that this might be reasonable. It's a trend which we notice in general. And the impact, we say that it's high, meaning that some reasonable action might produce a high impact. And it might sound simplistic as well, but normally the best practices are to calculate by performing a multiplication of the scales, 3 times 4, and then we find the risk level, which in this case is 12. So this could be characterized as a high risk. Number 37, for example, would have a moderate impact. So the risk could also be characterized as medium. So this could be harming workers' autonomy. So because we have implemented so many so many mitigation measures, so the risk can also be medium. The penultimate slide is also about this, the same exercise. So as you can see, we have, in general, we have identified five numbers in the scale of the risk, 5 points also in the scale of impact, and the product is calculated in the third one, so it's the same. So this from number 29 to 43, we have found the ethical risk. What comes before 29 is the legal and privacy risk, which I do not enumerate here just because it's not the focus of the presentation. So you can see that from 29 to 43, 14 risks, it's not, there are quite a lot of possible risks which could stem from this setting. And the last slide I dedicate for recommendations. As I said before, it's a very important step in the impact assessment procedure. Normally, recommendations in real life, how they come, we either avoid the risk, or transfer the risk, or mitigate, so we deal with it, or we accept, which means that we do not take any action, but in a sense that we cannot, of course, otherwise we would take some action. Some possible recommendations in these ethical risks and impact afterwards in these settings could be the continuous training and upskilling of the competencies of the workers, or to have efficient communication, to vote for, to support the efficient communication within the plant and care for the motivation and well-being of people. Or lastly, but not exhaustively, of course, it's to take precautions in the level of hardware, software, or also in organizational matters such as the safety procedure in the plant, so that to ensure an efficient collaboration between workers and robots. I think this concludes my presentation, and yes. I guess essentially we can open the discussion for if any remaining questions. Yes.
Thank you, Nikos. Very interesting. So I had a quick question about how did you do the impact assessment? So how did you provide this high risk, low risk? How do you gather this impact?
Yeah. No, I totally understand the question. It's not that I don't want to be to hide the details in that, but okay. essentially, since we speak about societal matters, and we can also include in the impact assessment the possibility of having a bias by the assessor, which is kind of a research topic itself. How can we ensure that the person who performs the impact assessment is not biased? That's why we include more than one person with different expertise. And how we conclude on the numbers. Personally, I don't think that this is enough, but this is common practice. For that, we try to identify if there are more lighter or more severe, let's say, consequences, impacts, and then we use a scale. That's what we do, based on what could have been done differently. So maybe it could be worse, maybe it could be better, but if there is a high impact, it's understandable in the very beginning. Also for the legal part, which is more prescribed in law compared to ethics, we have guidelines. So we have on data protection risks, there are quite a lot of guidelines from the supervisory authorities, data protection authorities, and sometimes we have guidelines from other projects, from the academia as well, right. Or from the, yes. So there are some methodologies provided by different parties.
Yeah, I saw a lot of concerns that are in your table that are very interesting and people don't talk often about, which is, for instance, deep bonds between machines and human and robot. So, but maybe it's a little bit outside of the scope of this workshop. Would be interesting to go in that in other occasions. So, thank you, Nikos and Matthias, for this introduction to the ethics issues. And with that, indeed, we kind of conclude the presentation sessions. And in principle, we should enter the discussion part of the workshop. And although we don't have a lot of time because we're supposed to end at 15:30, the discussion points that I have highlighted come back a little bit to the goal of the project, right? So, and what I also have listened, what we have listened during the day is that, so a lot of projects, a lot of efforts is put into giving robots more responsibility and giving humans only some sort of supervisory role, so that the humans will have a decreased physical and also cognitive effort in the industry domain. So I would like maybe someone wants to respond to this point, as well as with this human-robot collaboration endeavor. Are we really boosting industrial and economic growth? So maybe we can answer that question. There is some statistics that says, yes, we are boosting, we're losing types of jobs, but we are creating more jobs. It's not clear to me from this morning's presentations how right now we are impacting the economic growth with the solutions that we are working on in industry, in the robotics and industry applications of robotics. As well, there is a concern that autonomous robots will have a negative impact on our economic growth, exactly, and also pose a negative challenge for our culture. So maybe I would like to maybe tease Ismael with the first question, if Ismael, you're still there, whether what do you think about humans have less cognitive efforts in the industry domain? So is it something, given let's say cognitive abilities to the robots, and including morality and emotional, even morality and emotional intelligence, I see sometimes. So do we really challenge the role the humans are playing in industry? Or do you think this is going in the right direction?
I mean, in my opinion, the role that precisely enhancing robots with these cognitive capacities will help actually in industry to focus more the human cognitive capacities within whatever task at hand, to actually focus on the more demanding or more interesting cognitive skills, whereas I think the robots should play the role of focusing more on the more let's say boring or repetitive tasks that and the tasks that also have more physical load for the human. It should serve as a enhancing of the quality of the jobs at both levels, physical and cognitive. But of course, this can take many directions. I think Europe is putting a lot of effort in this kind of enhancing cooperation, like mutual cooperation. And for that, we need some kind of social intelligence in the part of the robots, so they are able to adapt to the human particularities. So.
Yeah, I would like also to ask Monica her opinion, because she had also in her presentation some activities that relate to understanding how we educate, or how we educate humans ourselves to design, build, and operate with robots. Maybe if you can give your opinion on how do you see, let's say, the influence of having robots with cognitive abilities in industry and also in academia. So I don't know if we will have professors that will be teaching us that are not humans.
Yes, thank you. In my opinion, yes, the role of robotics, of course, in industry and also in other productive sector. I think also to agriculture, health, and so on, is something that is becoming real. We can see up to now applications that are still preliminary, but they are quite promising. I think it's for sure a challenge from the human point of view, because the jobs are changing, and yeah, I see in this perspective an important role of education, because the education to robotics, learning about robots, is becoming important, not only at the university, but at least at the high school. And this is something that is becoming somehow presenting. Robots are becoming present in school, but they are not yet so structured. The education in robotics at school is something that is still not very organized. Let's say it's very different. It's very heterogeneous among different schools. So this is something that needs to be improved, in my opinion. Because for the job market, the advent of robotics, of automation, could be a problem, but also an opportunity, because new jobs are requiring a higher preparation, a higher background.
Mm-hmm. Okay, someone else wants to add to? Thank you, Monica. To Monica's. Okay, so maybe I would like then to go back to ethical issues a little bit. How does, for instance, Danielle, are you there? And the ethics experts, how do they see humans being operated with the resemblance of robots? So, do we have regulatory issues there? What is the problem with identity, for instance, the identity of the human being visualized by a robot? What is the problem there? Are we going to have problems? This is also true in industry. It's not only in the healthcare or social environments, but also in industry. You may have, work through robots. So where there will be less and less interaction with real humans. So are we prepared? You see that this is the future, and how will it impact, let's say, the human factor, let's say, of being human, the identity of being human? Danielle, are you there? Maybe left already? Okay. So maybe I will ask this question then to Matthias, whether you thought about it, because in the REHIB project, for instance, we also have robots that closely interact with patients, not with other industrial partners, or they're not building cars or dismantling electronic chips, but they're dealing with other humans. So do you see any issue of applying a system like Danielle, which, I don't know if you saw it, but also in the REHIB project, we have the typical what's called the digital twin, right? So we have a copy of the human in the software of the robot. So how do you see this influencing positively or negatively our culture, for instance?
Yeah, I mean, thanks for the question. I'm not sure if I understood the question perfectly, but from what you were saying, that the digital twin as a new phenomenon to be also assessed under the regulatory perspective.
Mm-hmm.
I think the digital twin is one of the topics that, like big data, like AI, challenges all the data protection principles and other ethical principles, more or less in the same way. So it just exacerbates the already existing issues we have with more traditional automatic processing of personal data. So it just makes it more massive, like the risks. But as I also said to Nikos yesterday, we don't only have risks, we also have legal and ethical opportunities. You can also rephrase all the risks into opportunities if you want, or you can also rephrase barriers, legal barriers, into challenges or opportunities. We know that machines can do some things maybe in a fairer way, or can be more easily audited, or etc. can more easily be checked for compliance with the law. So they have opportunities and also risks, but we tend to always just speak about the risks for the ethical and legal principles. The digital twin, I think, is not that you can pick out just one data protection principle, such as data minimization or so, but I think it just exacerbates the overall impact on the legislative framework.
Okay.
As you can also see by the AI ethics questionnaire, it's nothing is invented new there, although it's called AI. It's the same old principles that have been reapplied, but we are just trying to find new regulatory ways to more deeply build legal goals into technology. So that's why one way to do is to go to the technical standards community and to really find out how to build it into the technical specifications, to have some support of the legal goals, in addition to the policy layer.
Right. And now I think Europe is leading a little bit this regulatory endeavor, over AI specifically.
Exactly.
With this new definition of AI and all the rules. So there's a lot of talking about that.
We had this G7 meeting of the countries that all discussed, were overshadowed by the fact that the Chinese had this facial recognition standard pushed through ITU. And G7, one of the topics there was to discuss how to maintain the European values when international standardization is now adopting, for example, the Chinese values. This is really a big topic also at the very high level of politics.
Yes, there are a lot of discussion panels and webinars that you encounter in the internet. Also, there was one recently, just maybe yesterday or the day before, in Stanford on specific these issues with luminaries from the States. So we have to pay attention to these issues because all the industry and robotics industry and AI industry will be confronted with these regulations sooner or later. So, okay, so I don't know if any one of the people remaining in the workshop want to add any insights on these discussion points. I don't know, Sarah, do you have more questions maybe to pose?
No, really, I think your discussion has been, very nice, and only to give thanks to all the speakers and attendants for their time, because I know that at this point of the year we are very busy before the summer, and I think this has been A nice workshop, Anna. Very well organized. Thank you to you. Yeah, and very well conducted.
Well, we thank all the participants and the audience,
and thanks a lot to all the participants and the speakers. And for sure, we will go on collaborating.
Well, now we have open possibilities for people to talk to each other, and maybe there can be other workshops, less presentation-based, but more discussion-based. I think here there was a time restriction, and we just wanted to open doors to discussions, to these very interesting topics that we have to address, because we are experiencing a new revolution right now, and we're all in the same boat, we say. But before we leave, I would like to go to just send you a reminder, if you have a chance, and have a look at the Living Machines conference that will take place at the end of July. There will be, it's one-day lectures on specific biomimetic and biohybrid based type of robotics and AI. And as well, they will be running 6 workshops for 3 days in different area of the world, States, Japan, and Europe, and Australia. I don't know if in Australia. So have a look, and if you're interested, sign up. It's free this year because it's the 10th anniversary, and we are under COVID still, so it's free of charge. We will listen to incredible speakers, and so if you have a chance, just do that. And with that,
Anna, only one thing. The other Anna from Technalia from just wanted to for all the speakers to connect their cameras, and we can make
picture.
Let's say family picture, so we can send to everybody.
Yeah.
Also, before we do this, a big thank you to Sarah. Yeah, hello.
And Alex.
On behalf of CERT, so thank you all for this a very nice conference and workshop. Sarah and Anna, thank you for organizing and keeping also the schedule.
Apostolos, for telling you to everyone, is the leader of our HR Recycler project.
Actually, not officially, but
but in fact, you are the one.
Okay. I would like to thank all the speakers. It was really interesting, all these presentations, not only from ethical aspect, but also the technical, because we could see that how we could combine all this technical work with the ethical issues. Okay, so if we are ready, then we can have
the picture. Anna, maybe you can take away the sharing of
slide.
All the pictures are better.
Okay, how do I leave?
No, just
stop presenting.
No,
I'm tired. Stop presenting. Voila.
Okay.
But we don't have all the people at once, right?
Doesn't matter. The ones we are. Okay. So Anna, have you taken the official picture?
I don't know. I see myself in the corner.
Anita from Technalia?
Yeah.
We are just 1, 2, 3, 4, 5 people.
No, it doesn't matter. Just take the picture.
It looks more like a HR Recycler consortium picture.
Yeah.
Okay. It's okay.
All right. So thank you, guys. Thank you, Monica. You stayed until the end. Very courageous, very good. So we hope, we can talk again. Also, Matthias, thank you. And Nikos. I put a face now. I didn't see you ever. All right. So thanks a lot, and have a wonderful weekend.
Thank you.
You all deserve it.
Okay. Thank you.
Thank you very much.
Bye-bye.
Bye.
Thank you.
Thank you. Bye-bye.
Bye.
Ciao, Sara. Adiós. Buen fin de semana.